Hi, my name is Akash Kapoor, and I come from the business intelligence analytics background. I had been working for more than 2 decades, and my first interaction with SAS was in 2004. Let's get going with SAS programming. We're going to see what data analytics is, what SAS is, and different tools in the data analytics industry. And then we'll go into some of the programming techniques in SAS. So without further delay, let's get into what data analytics tools, what are the data exactly, what data analytics tools are, why SAS, what is SAS, SAS features, programming concepts, and a case study. We'll be doing a testing for randomness. Also, we'll be doing a testing for association, and then what are the job trends in SAS. Data analytics. Now actually going forward, no business is going to survive without data, or say without digging into the data. Data is already present, and now we need data analytics to get insights from the data. Let me give you a small example. I recently did a project for one of the e-commerce companies, and the purpose was to find out the propensity of buying by customers. Propensity of buying meaning likelihood of buying. So what I did was I collected the data from their website and then further bifurcated it into different variables or say features, be it a behavior, what day they are coming, how much time they are spending, which page do they come from, and there were certain others. Similarly, there were the demographics and how they are being acquired. There are certain ads from where they are coming or certain websites where they're coming from. So all those actually collated together, we came up with an inference that 72% of their orders are coming from 50% of their customers. So rest of the 50% are just contributing to 28% of the orders. Now, when you get this insight, you will actually be marketing to the above 50%. So your return on investment would be good. You can upsell, cross-sell to these people. They'll buy easily than the other 50%. So this is what data analytics can do for you. Data analytics paves the way for the creation of next-gen products. So this is one of the case studies which I just spoke about. And on this, you can develop a product where you can put in the parameters and it gives you a result whether this person is going to buy or not. It will help you actually use manage resources or data analytics manage resources so as to reduce cost. Now, as I mentioned with this example, you can reduce cost by actually upselling, cross-selling to this top 50% where you don't have to put more resources, but you'll see they'll be buying and your return on investment is going to be more. Analytics enables better work-related decisions. Of course, you are more informed with the historical trend of data. Some patterns are there, so you can take a better decision. Meeting customer needs through better services. Now, it's one of the examples which I gave right now. There are others like recommendation engines. Recommendation engines, for example, if you are going to some e-commerce website like Amazon or Flipkart, or there are several others. You see whenever you buy something, based on your trend or based on the people who have bought something, there are some recommendations. So meeting customer needs through better services. So instead of searching the entire website, they come up with these are the things other people have bought, so you may be interested in that. So they are trying to match your needs, match the needs of the people who are buying a certain product. So that is like meeting customer needs through better services. There are several tools in the market for analytics. There are paid tools, there are open source tools. In the paid tools, SAS actually holds in the leaders quadrant of Gartner. There are other visualization tools like Tableau. Excel is a good old tool, ClickView, Splunk, and open source R is actually coming up fast, so is Python. And I would say in the open source tools, R is right now leading, but Python is coming up because of more features in Python than what R has. Apache Spark, Apache Storm, Pig, and Hive, these are the last three are actually components of Hadoop. So these are other tools which are used for data analytics. Now, why SAS? There are so many tools in the market. Why SAS? Few of the aspects for SAS are ease of learning, data handling capabilities, graphical capabilities, advancement in tools, and job scenario. We'll look at this. one by one. Ease of learning. SAS is easy to learn and provides easy options. Proc SQL for people who already know SQL. So you can write SQL, you just have to write Proc SQL for SAS to know that the next statements are actually going to be SQL statements, and at the end you write a quit. R, on the other hand, has a very steep learning curve as it is a low-level programming language. I have actually worked on R as well, but I felt that it really is a steep learning curve compared to SAS. So SAS is easy to learn, and now you have SAS Enterprise Guide, which is like menu-driven and even much easier than writing just base SAS. Data handling capabilities. SAS is on par with all leading tools, including R and Python, when it comes to handling huge amount of data and options for parallel computation. So whenever actually you're creating a model, you would need historical data. And a tool which cannot handle the large amount of data will not succeed, because more data you have, better is your prediction. Let's say you have to develop a model and you can just handle data for like last 2 years compared to another tool which can handle data for the last 10 years. The one which is bringing the data for 10 years is going to give you better prediction than a tool which is actually just handling data for 2 years. So data capacity handling, data handling capabilities are good in SAS, and that's what makes a predictive or statistical tool much more robust, I would say, much more better in the predictions. So SAS scores there as well. Graphical capabilities. SAS provides the functional graphical capabilities with a little bit of learning. It is possible to customize on these plots. So of course you can actually draw the plots, or graphical representation is there in SAS. And with graphical representation, for example, you have a data set, you want to see the outliers, it's better to see in a graphical representation than in a tabular representation. So SAS also scores here. Advancement in tools. SAS releases updates in controlled environment, hence they are well tested. R and Python, on the other hand, have open contribution, and there are chances of errors in the latest development. So the difference between open source and licensed software is that a licensed software, they'll actually be releasing patches which are already tested. You will get a support, whereas in contrast, the open source tools, anyone can contribute with patches, but are they tested or they're not tested, we don't know. Other piece is you're getting stuck, so there is no way to get a support for that. It's just that you have to Google it and see if someone has ever got stuck on such an incident. And that's the major difference between the open source and a licensed tool. Job scenario. Globally, SAS is the market leader in available corporate jobs. In India, SAS controls about 70% of the data analytics market share compared to 15% for R. So the further to add to that, worldwide SAS has like 35% share, which is a market leader other than compared to rest of the tools. And I believe that trend is going to go ahead, because SAS actually, we have already seen the different aspects of SAS, and being the market leader, being in the leaders magic quadrant of Gartner, 70% of the jobs are being controlled by SAS in analytics industry. So all the trends are pointing towards SAS is the leader and will be staying going forward. So what is SAS? We already saw the features, the aspect, ease of learning, graphical usage, data handling capacity, job trends, etc. Now let's dig into what is SAS. SAS is Statistical Analytics System. Is a software suite of advanced analytics, multivariate analysis, business intelligence, data management, and predictive analytics. SAS has come with actually several of its products. SAS is for statistical analysis for sure. It's used for BI reporting. It is used, there is a component for data integration in SAS. It's like an ETL tool like Dataset, Informatica, etc. SAS is also used for project management, for quality assurance. And SAS has now come up with dedicated products for industries like clinical trials. So they are coming up with more and more products. And now actually they have a robust set of products where you can go vertical wise. Also SAS has certification which actually gives you something good on your CV that you're a base SAS certified or you are a SAS business analyst, advanced programming certified, and so on. It is developed by SAS Institute. SAS provides graphical point and click user interface for non-technical users and more advanced options through SAS language. So you can do a SAS language, write a SAS language, and you can also do a point and click. SAS language is like the base SAS. Even if you are doing a point and click, at the back end, it's the base SAS which is being written. So there is an ease of use now with the graphical user interface coming in. SAS Enterprise Guide is the example for this. And you can even learn SAS depending upon what our requirements are. So SAS, again, flexible, extensible, integrated, and powerful. So what all that ties up to is it provides business solutions. Business solutions, for example, I gave you the example of this e-commerce company where we are actually trying to find out the propensity of buying. So that's a business solution or a recommendation through SAS. Analytics, of course, you can do the reporting, the decision reporting, the tactical reporting, the operational reporting, data access and management. You have the SAS Data Integrator for that. Reporting and graphics, of course, that's part of the analytics piece. And visualization and discovery. So whenever you are doing any, or say whenever you get a data set, you would like to visualize it as to how the data is scattered. Are there any outliers? So you can discover some outliers and maybe there's a treatment for that you want to do. So all that is possible with SAS. Let's look at some of the features. I've already explained some of them, but we can go into that again. Data access. So SAS can connect to different databases. It can connect to the flat files. It can connect to the structured databases like Oracle or SQL Server or Netezza. So it has all those capabilities. Reporting, of course, as I mentioned in the last slide. So once you have the data in, there is a data set created in SAS. Once a data set is created, you can merge the data sets or do some vertical or a horizontal cutting of the data to come up with the report what is required by the business. So SAS is very much capable of that. Transformations, once you have the data, you can do a transformation, or when you're pulling the data, you can do a transformation through SAS Data Integrator. That's the ETL tool. So it is very much capable of the entire BI stack, which is like the data set, or say the database, and then you have the ETL and then the reporting piece. So all those SAS is capable of. SAS Framework. So SAS Framework, accessing the data, manage, analyze, and present. In any of the data science project, what we have is we collect the data, which is like accessing the data, manage the data, which is manipulating or data preparation, analyzing it, creating the model, and presenting it, inference or the storytelling. So the SAS framework actually is capable of all these data science pieces, or the 4 phases of the data science. Let's see, access. Now, accessing the data, it could be the flat file, CSV, Excel, text file, or some structured database, SAS, SQL, Oracle. It has the capability to get the data for you. Once you get the data, you can manage it, subsetting it, creating variables, validate, clean, merging the data set, pending the data set. So this is the data manipulation piece, what you're seeing in the manage part. Then you have the analyze. Analyze is you're creating the model here, maybe a regression model, forecasting models, or just a simple descriptive statistics. And then you have presenting it. Summary reports, list reports, or the graphical representation, whatever suits. And SAS is very much capable of all the 4 components of data science, all the 4 phases of the data science. Some of the SAS components include base SAS, is the most widely used component. It has data management facility and also lets you analyze data. Now, any code you're writing, or say any graphical tool you're using in SAS, be it the SAS Enterprise Guide, or there's a transformation tool, SAS Data Integrator, behind the scene, there is a base SAS code which is being written by SAS. Instead of you writing it, SAS writes it because SAS understands base SAS. So SAS In the base SAS trainings, you learn the base SAS, which is actually the language which SAS understands. So base SAS is now being most widely used component. Graphs and representation make understanding easier. So graphical for us to figure out the outliers or some trends, some patterns, graphical representation. Is there SAS Stat lets you perform statistical analysis with variance analysis. The various analysis be descriptive or predictive. So SAS Stat allows you that. SAS ETS is suited for time series analysis. So you can do time series analysis, just look for the moving averages and so on to forecast something. Those things can be covered in SAS ETS. Programming concepts in SAS. Let's have a look at some programming concepts in SAS. Let's write a program to print the first 10 Fibonacci numbers. For a Fibonacci series, I have here. So what we are doing is we are actually doing 10 iterations. I am going from 1 to 10. We are going to execute the loop in this. What we are doing is we are creating a variable called fib, and we are actually having these numbers and the lag of numbers, summation of that, and we are, if I is equal to 1, then fib is 1, and we are going till I goes to 10. So I'm just going to run this code. In this code, a data set called Fibonacci will be created, and now I'm going to print this data set. Here we have I going from 1 to 10 and the summation of Fibonacci series number and the lag in the previous number. This is how it is going to be. 1 plus 1 is, so it was 1 here, 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on. So that's a small data set being created here. Let's have a look at more code. And let me explain you the code here. We define a variable fib to find the next Fibonacci number. Fib variable is equal to the sum of the current fib number and the previous fib number. The lag function is used to retrieve the last function and patches the value of the previous fib number. Now this lag function which is being used, you can use a lag of 2. Here it's by default it's a lag of 1. So the previous number, lag of 2 is like 2 numbers back. Now this lag function can be used in, for example, there is an insurance company and you have losses, or say the profit, let's say take losses of quarter 1, quarter 2, quarter 3, quarter 4 by policies, or say in a single policy you have the losses for quarter 1, quarter 2, quarter 3, quarter 4, and now you create another variable where you lag it by 1. So where you had quarter 1, there'll be a blank. Quarter 2, you'll be having next to it would be a quarter 1 data. So that way what you can do is create another variable where you have Q2 minus Q1. You can see what is the difference. Is Q2 better than Q1 or not? Similarly, Q3 minus Q2 and so on. In our SAS class, we can actually represent this with a more with an example. Here I just wanted to let you know about a bit of the lag function. Proc step split the dataset to dataset Fibonacci. So whenever the SAS runs this, a data step, it will create a data step for you, but it's not going to print data set for you. For that, you have to explicitly give a print command. We get 3 columns in our output data set. Observations. Observations is a column which comes by default, and if you don't want that, we have to write no obs. I is the iterations what we got here, and fib is the variable which we created. So obs in I go from 1 to 10, whereas fib contains the first 10 Fibonacci numbers. So it's a summation of Fibonacci number plus the lag of it. Data is central to every data set. In SAS, data is available in tabular form. Variables occupy the column space and observations occupy the row space. Now, the SAS data set is very much like a spreadsheet and an Excel sheet. So here the columns are called variables and the rows are called observations. That's the terminology being used in SAS. So people from data warehouse or ETL backgrounds, or even the reporting backgrounds, Cognos or SSRS or OBIE. So here The terminology, as I mentioned, they might be using columns and rows, so we use variables and observations here. SAS treats numbers as numeric data and everything else falls under character data, and SAS has two types of data. So instead of string varchar, it just has numeric and character. That's the two types of data what SAS deals with. SAS date, now this is something important because how SAS treats the date. SAS has a different way of treating the date. Let's say here is a number line and this is 0, this is +1 and so on. This side is all negative. Let's say this is -1. 0 here corresponds to 1st January 1960. 0 corresponds to 1st January 1960. Anything on the right of it or after it is a plus. Meaning 2nd January 1960, SAS will read it as 1. 31st December 1959, SAS will read it as -1. So SAS treats dates as numeric. Now, in the base SAS exam, they generally ask this question. So this is very important. Whenever you bring the date in SAS data set, you will see a number, 2,500 or whatever, depending upon the date. And that's the reason why you see it that way, because 1st January 1960 is treated as 0. Anything after that is all positive numbers. Anything before that is all negative numbers. As apart from these, dates in SAS are represented in a special way. A SAS date is a numeric value equal to the number of days since 1st January 1960. As I mentioned, 1st January 1960 is taken as 0. Anything before that is negative. Anything after that is all positive. Apart from date values, there are many tools to work on dates, such as informats for reading dates, functions for manipulating dates, and formats for printing the dates. So how the date is coming in, you use informat for that. How you want the date to be written, because SAS is going to just write a number, as you're seeing on the right side. How do you want to write it? There are different formats to write the dates. Okay, informats, as I mentioned just now, that informats is how SAS has to read the data. For a character data, you write a $sign with the width of the or the length of the data. Reads character data length of W. Numeric is width dot decimal, reads numeric data of length W with D decimal points. And date is MMDDYY. I mean, that's the format. There are different ways of writing the date. How it is coming in, Informat actually tells SAS how to read this data. Format is something which tells SAS how to write the data. When you're reading the data from the input file and you want it to be written in a certain other format, so you use a format for that. So Informat is to read and format is to write the data from SAS. SAS data format example. For example, here we have the birthday and we are creating a new data set. We are reading from the sample data set and we are creating a data set called formatted, students formatted, and we want the birthday in MMDDYY 10 dot. So that format, this is going to change in this format. It's like MM/DD/YYYY. So that's how it gets changed. So this is the format. And when you might have read this file, you'll say inputting how the data is coming in. Loops in SAS are of 3 types. A do statement, that's the simplest of loops. Do statement is like you execute certain statement within the do loop. If this is this, if losses are greater than say 200, do this. So it will keep on doing it till say as long as the losses are 200, above greater than 200. Do until and do while. So they also do the same stuff but what they do is do until will check the condition after executing the first iteration, whereas do while will execute it before. So if the condition is met, do while will not give you anything at all, whereas do until will execute at least once and then check for the condition. So do while checks it at the top and do until checks it at the bottom. That's the difference in do until and do while statements, and that makes a base SAS exam question as well. Let's see what appending and merging means. They are both actually combining the data sets, but appending does a vertical concatenation, whereas merging does a horizontal concatenation. Let's understand this with an example. If we have, let's say, a variable A, variable B, oops, and there is another data set where we have variable A, variable C. So C001, C002, C003. Let's say there are 4 observations. And this variable may be like an expenses. And here we have another data set. Let's say data set 1 and data set 2. And here we have C008, C002, C001, and C005. And let's say this could be that for this person has what make of car? Let's say they have Maruti, Toyota, Honda, and Hyundai. Now when you do a vertical concatenation or say appending of 2 data sets, what will happen is a new data set is created, which is like this. This is appending or a vertical concatenation. Now for merging, what will happen is you have C001, you have C002. These two will go off. This is called the horizontal concatenation or merging. See the difference? With merging, if you have a matching key, the records are tagged horizontally, or this is called the horizontal concatenation and vertical concatenation. The condition for merging is your variable on which you are actually combining the data set that should be sorted. Although it's not sorted here, the purpose was just to show you an example. So this is the difference between merging and appending. SAS procedures. So SAS actually has just 2 components, the data step and the proc step. There are several procedures in SAS. Import data sets to manipulate the data set. Contents is like for getting the metadata. Print, just to get the data set printed. Frequency, this can be used for different, with the frequency, it could be a cross tabulation. It could be for just one variable, or there are other like chi-square tests, etc. you can do with frequency. Sort, proc sort actually works in sorting the data set on whatever variable, be it ascending or descending. Format is if you want some format to be defined on a data set, you can define the format and apply it into different data sets. Proc survey select. Proc survey select is if you want to randomly select some data or samples of data from a data set. Proc survey select can be used. There are different ways of selecting or different methods. You can use proc survey select as well. Transpose is like when you convert rows into columns, you can use proc transpose. Proc means for descriptive statistics. Summary is if you want, it works the same as proc means. It's just that proc means by default gives the data set printed. For summary, you have to explicitly write a proc print command. Proc rank is you want to rank data based on certain variable. Proc options is if you want to see what are the options available. For example, you have obs, first obs, drop, keep. These are all options which comes with SAS by default, so you can actually see that with the proc as well. Proc export is once if you want to export the file. That's where you can use proc export. Proc Means is one of the most powerful and flexible procedures in SAS. So it gives the descriptive analytics. Once you run a Proc Means, by default, it will give you a number of observations, maximum, minimum, some and standard deviation. But if you want others, you can always write what are the things you want to have. For example, here we are grouping it by sex. So class sex. In variables are age, height, and weight. For females, there are 9 observations: minimum age, maximum age, the sum, the mean, median, standard deviation, and the range. So this Proc Means can give you a good set of good statistics, descriptive statistics. Let's see the testing of randomness. So here what we are going to do is we're going to play with this file where we have like 10 billion records, and I'm just going to run the code on this to check for randomness. Now in randomness, we are going to use proc frac with chi-square, and here this is the small code. Let me actually, in this case, our null hypothesis is that the numbers selected are random, and alternate hypothesis is they are not random. So once I run this code, let me explain you this code. First of all, we are actually creating a data set called test, and we are calling a file pi10billion.txt. We are inputting there is one digit, and whether it's being randomly selected. Order is capturing the iterations. This is the automatic variable being captured. Proc frac, we are writing the proc frac or checking for randomness for the variable digit, and with the chi-square. Setting the width of each number. Width is like 1 dot because it's written in the same row. We use a double at the rate that it holds the number, and then it goes to the next number, goes to the next observations or next row. That's the reason we have the double at the rate, and 1 is the length of the digit. As I mentioned, as it's an automatic variable being captured in the variable order, and here we are running the chi-square test. Instead of 2, I'll be running for one of them, and I'll do another test. See, we already have, and if I run a proc frac on this, we'll get a simple statistics, and then we get the chi-square test. Frequency, percent, cumulative frequency, and so on. And here we get the chi-square test. We get the chi-square value of 2.78, but the p-value here is 0.972. 0.972, which means we will fail to reject the null hypothesis, and we will conclude that the numbers selected are random. The numbers selected are random. So the p-value is telling us that we failed to reject the null hypothesis, and the numbers are random, which was our null hypothesis. Now another example we can go with is a test of association with chi-square or proc frac. Now test of association, what this does is, here the null hypothesis is variables are independent, and our alternate hypothesis is they are associated. So it's a test of association, what we are doing with chi-square test. Let's see, here is the data set for auto industry, or say from auto dealer. You have the make of the cars, the price, miles per gallon, representative who sold it, whether it's a foreign make or a domestic make. I will just create this data set and print it for us. Here is the data set. Now the other way is, see, one of the ways is we just do a price versus miles per gallon. Price versus miles per gallon. Price is a digit and miles per gallon is also a digit. So there'll be a contingency table or a cross tabulation which will not make much sense. Instead, what we will be doing is we will use another procedure called proc format. We are saying that creating a format called PR, and we are actually defining low price, mid price, and high price. Similarly for miles per gallon, whether it's a low, average, or high, we create this format, two formats, MP and PR, and then we apply this format to our data set. This is a usage of proc format. We apply this format to price and miles per gallon. I'll just show you what the new data set looks like, and then we do a test of association on it. We do a proc print here. Let's see. Our price in miles per gallon looks like this. Now, if I do a cross-tabulation of this to find out if there is an association between price and miles per gallon, this will give me a much better picture. We will get the cross-tabulation. We will also get the chi-square because we asked for it. See here. The prices are low and the average is high, or the miles per gallon is high. We have 11.54% population in this data set who have low priced and high miles per gallon. That is actually something which is desirable. You can also go for the luxury segment where the prices are high and miles per gallon is going to be low. So price is high and miles per gallon high. We don't have anything in this data set. Now going forward, another thing what we wanted to do is when we run a chi-square test for association, we get several other tests or statistics. What we are concerned with is a chi-square here, and I see a 0.21%. The probability is 0.21. In this case, we will accept the null hypothesis that they are independent. Price and miles per gallon are independent. They are not associated. Since our p-value is 0.21. Generally in the industry or the academics, 0.05 is the p-value. What is considered anything below that, you reject the null hypothesis, else you accept the null hypothesis. So in this case, we'll accept the null hypothesis and say they are independent. Right, so that was the test for association. Another piece what we can actually look at is the job trends. So the job trends, the following is the job trend of SAS. Now if you look at the job trends, SAS and SAS modeling job trends. So the term SAS and SAS modeling, we are seeing in 2015, February 2017, the jobs, the data analytics jobs, 47% listed SAS. SAS modeling was listed by 11%. So then it could be that both of them there. But percentage-wise, if you see 47% of all the data analytics jobs which are listed, so that makes like a huge impact that 47% of the data analytics jobs are actually showing the trend or the word SAS in it. So SAS has been a market leader when it comes to data analytics tools. Of course, this is visible now. And the trend had been going up and down, but still it captures 47% as of this year, February 15th. Right, so just a quick recap. We talked about the data analytics tools, the paid tools, the open source tools, where SAS stands as far as data analytics tools are concerned. Why SAS? Because of ease of learning, the data handling capabilities, graphical capabilities, advanced embedded tools, job scenarios. What is SAS and the SAS features? We also looked at some of the programming concepts in SAS, the test for randomness, the tests, the association test, and what the job trends in SAS today are. So with that, I come to the end of this presentation. I hope you enjoyed it and you'll be considering SAS as the analytics tool going forward. And as I mentioned, it has a great potential, ease of learning, and it can do all the data science. It can take you through all the data science phases which you will be requiring actually going forward, because data science is something which is like a hot market job right now. And with that, I come to the end of the presentation. Thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!